Hello, I'm Ben Tillett, one of the product owners at Pebble Beach Systems. Today I'm going to talk to you about our new platform, Oceans. As broadcast industry operations increasingly transition to IP, making good decisions around technology refresh cycles is key. And there is little doubt that many of the decisions made in 2020 need to have the cloud at their heart. This is why we are delighted to announce Oceans, a new wave of technology from Pebble, the broadcast solutions experts. Oceans is Pebble's next-generation service-oriented technology platform built for all clouds, but equally happy on-prem. Oceans will enable you to deploy, manage, host, and upgrade your broadcast workflows and services from a single intuitive unified interface, now and in your IP future. With common core services across multiple functional applications, Oceans provides greater visibility and control of your playout infrastructure. And regardless of scale, you can expand your deployment as new services are released and write and integrate your own functionality using Ocean's open and secure APIs. Ocean's virtual container-based platform management ensures you're running the most efficient solution for your unique operations at any time, optimizing the provisioning, management, and usage of available resources. Oceans delivers a choice of cloud or on-prem, with the ability for hybrid deployments and migration to new hosting infrastructures. Centralized and simplified access to core functionality, including deployment and update tools. The ability to exploit the newest technology by upgrading to access new solutions from Pebble or by controlling third-party technology using open standards. Remarkable adaptability, allowing users to write their own business logic and functionality. A continuing journey with Pebble, providing interfaces to existing installed Pebble solutions and a shared roadmap for the future. Exceptional resilience, distributed load-balanced, self-aware, self-healing technology to safeguard operations. And baked-in security, thanks to configurable user permissions, authentication, authorization, encryption, and logging. The first step to building a new platform is to ensure that we have solid foundations. We have two classifications of service, the first being platform services. These are the core services required to ensure the platform works properly. The second type is functional services. As the name implies, these are services which contain the user-related functionality. Some of the platform services we've built include a deployment service. This is a service which interacts with the bare metal hosts to install and manage software packages. It is also responsible for container management. The permission service is responsible for user authentication and authorization, and the UI service is the Oceans front end for the platform, which can be scaled out as required. In our first release, we will support the deployment of Lighthouse and some of its other services, our new IP-based connection management system, and a new orchestration engine for broadcast workflows. There's a lot of buzz on the market about microservices architectures, but we decided to take a step back and look at our use case, and in the end we've selected a service-oriented architecture for Oceans. A service-oriented architecture, SOA, breaks functionality into a number of small programs, each responsible for servicing one set of related functionality, all working together to do what the user needs. Here is an example of two different video processing applications. The top one might be a playout engine which is doing a lot of real-time video processing with a very small internal buffer. Trying to break that out into multiple services that scale over a number of machines isn't very practical today. Whilst looking at something like OTT delivery, it's clear that it's possible to break that up. Ultimately, this all comes down to picking a service size that meets the use case. Therefore, we'll use a large, small, or microservice as appropriate. Just to quickly go over the technology stack within Oceans. Oceans makes use of Docker and Kubernetes for container management. Oceans interacts directly with Kubernetes to deploy and manage the system. It uses Isto and RabbitMQ for internal communications, MetalLB for external load balancing. Currently, Oceans uses MariaDB and MongoDB for its databases, and ELK stack for logging and telemetry data. One of our most important goals is to make Oceans a secure platform. We've integrated security checks throughout our development cycle using code analyzers. For example, this would catch hard-coded passwords or encryption keys during development. Oceans will ship with HTTPS enabled by default, which will ensure connections to Oceans are secure. Having a secure Kubernetes environment is very important, so we have used the least privilege admin model with our deployment. We have also ensured coverage of the OSWAP top 10 web application security risks. We'll also be aiming to follow all of the EBU cybersecurity recommendations included in R143, which include Active Directory support, which is on our near-term roadmap. Let's take a look at how we deploy software into Oceans. We've built a simple and intuitive model for deploying software into Oceans. Services will be packaged into software bundles, which can contain one or more services and the descriptions of how each service is deployed. The software bundle will also contain metadata about each service's dependencies, which will allow Oceans to know what services are required to run. Oceans will also manage the redundancy and scaling of a service. Let's take a look at a demo of the bundle uploads and service deployment. First thing we do is log into Oceans. We then select the Catalog Management view. This has a list of all the bits of software we've already uploaded. We can select a new bundle and drag it in to upload it. Once the upload's complete, it will unpack and the software will be available to install. We'll get a notification pop up when that's complete. We can also upload software in the background. So we can drag another version of Lighthouse in and continue using the UI whilst it uploads. If we create a new service, select Lighthouse. Once we click to the next screen, we can see that the dependency on MongoDB. This will be handled by the software and it will create an instance that includes that. We can now see the Lighthouse and MongoDB services starting up. Both of the services now showing green. We can see that Lighthouse is now turned up on the navbar on the left-hand side. And when we click, we can see that there is an instance of Lighthouse now available. One of the most important aspects of building a micro or service-oriented architecture is ensuring backwards and forwards compatibility. We've done this in Oceans by utilizing an industry standard tool called Pact. For each of the services we have built, there exists an API definition or contract. This is used during our development process to ensure that there are no breaking changes introduced without our explicit knowledge. This allows us to manage our API versioning and ultimately allows upgrades of isolated parts of Oceans. Oceans will manage the upgrade process of services. Operationally, this is a really simple process. Once a new software bundle is available, the user will be made aware that an upgrade is available. Before an upgrade can be triggered, Oceans will perform a dependency check to verify that the upgrade is allowed. Once the upgrade has been verified, Oceans will perform a rolling upgrade of that service. So in summary, Oceans draws on our wealth of experience and uses new tools and technologies and thinking to build a modular platform for the future which supports a cloud infrastructure. Our rigorous approach to security, authentication and resilience means that the building blocks are in place for functional services which encompass and also expand beyond the playout tools we are known for. And we're delighted to confirm that we have recently been given Best of Show by TVB Europe as part of the virtual IBC activities.